Good afternoon and welcome to another episode of The Angry Astronaut. Sorry it's taken me so long to come out with this one. I made a commitment in a previous video to put out a video about UFO navigation if the previous video hit 4,000 likes. Well, it's long since passed that milestone, and so first of all, sorry for taking this long, but I hope you enjoy this particular topic. So a lot of people don't realize that the whole idea of navigating between stars is actually a very, very difficult thing to do. As a matter of fact, we're not even entirely certain about our measured distances between stars. There may be interfering dust or other mitigating circumstances between us and the star in question that could modify the actual distance between us and a distant solar system. And if we don't really know how far away a solar system is, then how do we navigate to it? And also, if you're traveling very close to the speed of light, your entire perception of the universe changes drastically. And if you're not traveling that fast, it's going to take forever to travel between stars, even stars that are very close to one another. So how are alien civilizations doing it? What are the methods that they might use? Well, interestingly enough, Carl Sagan and others some time ago discovered a very effective and reliable way to travel between the stars. So effective, actually, that they put our precise location on the Pioneer plaque that, of course, went out with the Pioneer spacecraft, identifying where we were in relation to some objects in the galaxy that were easy to identify and maintained their location and behavior for a very long period of time. In other words, if another civilization were to stumble across the Pioneer plaque thousands of years from now, they would still be able to find us because of these amazing objects. These objects are called pulsars. And even though some time ago astronomers determined that they were natural objects, some astronomers are not quite so sure anymore. Good afternoon. Once again, welcome to The Angry Astronaut. Really quickly, just want to let you know that I've added another tour date. I'm going to be coming to New York, to Long Island, actually. I was offered a space not too far away from New York City. Apparently a fairly easy train ride, not the easiest thing in the world if you happen to live in the city itself, but nevertheless, very, very large population in that region, so I think it might be a good idea for me to come there, especially since the space has been so generously provided at a very, very competitive price. All the details will be in the description. And once again, if you want to support this tour and keep it going, because it is going to be a pretty substantial investment, well, all of the details once again in the description. Let's move on to the topic at hand. So we've all, well, most of us anyway, who like astronomy, like spaceflight, etc., have heard of pulsars. Pulsars are amazing objects that come about as the result of collapsing stars in the aftermath of massive supernova explosions. Very, very unusual supernova explosions, actually, because most of them result in the creation of something called a neutron star, something that really doesn't behave the same as a pulsar. But pulsars themselves are extremely unusual when they come into existence and behave very strangely indeed. And so the astronomers in question who have been studying these objects began to ask some interesting questions. When pulsars were first discovered, the overwhelming conclusion was that they had to be artificial because they repeated very predictably. They pulsed out enormous amounts of energy as reliably as a lighthouse, actually far more reliably than a lighthouse, so reliably that some of them are more precise than our atomic clocks. So how could they not be artificial? Since then, of course, we've come up with some very good reasons as to why they have to be natural objects. But does this necessarily mean that all of them are? Or that perhaps other civilizations may have modified these pulsars in order to make them more useful? Because let me tell you something, some of these objects are so mind-bogglingly useful. It makes you wonder, are we sure that all of these things are entirely natural? This is the brainchild of Carl Sagan, known as the Pioneer plaque that was sent out on the 1972 Pioneer 10 and also the 1973 Pioneer 11. Carl Sagan had the idea of conveying a very basic message to other civilizations as to what we might look like, where we were in relation to other planets in the solar system, what these planets look like generally, but most importantly, where our solar system was in relation to other stars in the galaxy. Now, this was the most difficult thing of all. How the hell do you tell another civilization that doesn't speak our language, doesn't use our numerical system, how to find a solar system that's constantly in motion in the galaxy? Well, with pulsars. Each of these lines that you see on the middle to left-hand side of the plaque is an illustration of a particular pulsar. And how are we communicating this information? By communicating a binary code on each one of these lines that illustrates the unique periodicity of the pulsar in question and its relative distance to the sun. And here's the most amazing thing of all. The periodicity is something that another civilization would have an easy time identifying, and also it doesn't change, as far as we know, even over periods of thousands of years. And as you're about to discover, pulsars are actually much more useful to interstellar navigation than even Carl Sagan thought. And this is why a couple of scientists came out with some peer-reviewed papers a few years ago exploring the possibility of pulsars either being artificially manipulated objects or engineered objects rather than naturally occurring objects. One of the primary reasons that this is being explored is the fact that there are two types of pulsars. One of them is a traditional pulsar that has a periodicity of about half a second, rotating, that is to say, twice per second, and then you have millisecond pulsars, which rotate at an unbelievable speed and maintain that periodicity so precisely that you can set atomic clocks to it. Millisecond pulsars are unique, they are unusual, and we still are not entirely certain as to why they form. But there is something that is very unusual about them. About 12% of the population is concentrated along the galactic equator in an arrow-like clump. The number of pulsars progressively rising with increasing longitude until at a specific longitude point in the galaxy, their concentration drops precipitously by almost threefold, as if to mark this location precisely. According to our current understanding of natural stellar evolution, there is no logical reason as to why these pulsars are concentrated in this particular fashion, nor why they should have been arranged in such a strange shape. But if they are being used as some sort of navigation point that anybody in the galaxy could find, well, they are very useful indeed. But that's just for openers. Another paper, published again in a peer-reviewed journal, the Cambridge University Press, explores exactly why we decided that pulsars were not artificial after we thought they were back in 1967. There were 5 particular reasons, and 4 of those reasons are actually pretty bad and not really very good justifications. First of all, it is thought that the energy necessary in order to create the energy that we see from pulsars is simply too vast to be generated by any extraterrestrial civilization. How do we know that? How do we know that a Kardashev Level 2 civilization couldn't harness enough power in order to produce the necessary signals, the necessary energy that we observe in pulsars? Or even if they are just modifying their behavior, that might not require that much energy at all. In addition, other sources of pulsation were quickly found. That is to say, pulsars were discovered throughout the universe. So why would little green men across the galaxy or across the universe all use pulsars for some sort of communications beacon? Well, once again, I think that is actually highly unlikely. Pulsars pour out far more energy than it would be necessary for any kind of communications beacon, but if they're being used for navigation and you want to make sure they're detectable from even the most remote parts of the galaxy, well then of course you would see them duplicated across the galaxy or across the universe if they were such a commonly useful method of navigation, and many other civilizations could all come to the same conclusion and use pulsars for the same purpose, because after all, even Carl Sagan is making use of them, and if he had the ability to modify them to make them more useful to the human civilization, you can bet that he would probably do that. Thirdly, the source did not come from a planet and therefore could not come from an intelligent civilization. That's about the stupidest justification of all. No civilization in their right mind would want to put something as dangerous as a pulsar in their home system, but if they're capable of interstellar travel, as even our civilization may be able to do within the next century or so, then why couldn't they create these things in another star system safely away from their own, and yet close enough to be useful? Once again, a dumb justification. Number 4, the source was not narrowband. Pulsars generate their signal across a very broad band. Again, that makes sense if pulsars are being used for communication, but I don't think they're being used for that. They're being used for navigation, and if you want to make sure they can be detected across the galaxy and indeed across the universe, you want to make sure that the signal is broadband. There is only one justification that makes any sense out of the 5. There exists a natural model explaining pulsars. That one makes perfect sense. We have a very good natural explanation as to why pulsars come into existence. What we don't have, however, is why that natural model creates such uniquely unusual pulsars with specific and unique periodicities, some of which are unbelievably useful to navigation. The paper goes on to compare GPS with pulsar navigation and points out how similar they are in many respects. First of all, they're both highly accurate navigation systems. Both pulsars and GPS satellites broadcast a regular signal for unambiguous identification. They are both passive navigation solutions because no transmission between the user and the satellite or the pulsar is needed. However, GPS satellites broadcast their time and position, while pulsar distances must be evaluated with astronomical observations. But here's the most amazing thing. The periodicity of the signal is extremely important in order for the navigator to determine their exact location. GPS satellites are very, very precise, within 100 nanoseconds with every pulse. Very precise indeed. However, millisecond pulsars are precise within 3 nanoseconds. And while there is no natural explanation as to why pulsars evolved to have such a precise level of periodicity, a level of precision that is matched by virtually nothing else in the universe, there's a lot of practical reasons as to why it needs to be so precise. Interstellar distances are, of course, very, very huge. You need to have this kind of precision in order to make sure you're navigating to the right point in the galaxy, especially given the fact that everything is constantly in motion. And when you're traveling close to the speed of light, funny things start to happen. time slows down. The traveler's visual perception of the universe is compacted into a halo in front of the spacecraft. There is nothing around the spacecraft except inky blackness with a halo of light directly ahead. How can you possibly navigate when your visual perceptions are so off? When you have constant signals being generated by pulsars with a very easily identified periodicity, well, that's how you could continue to navigate accurately even under such difficult circumstances. So here are the 4 extremely important characteristics of pulsars that make them so damn useful to navigation. Number 1, entirely passive. Number 2, the navigational accuracy of pulsars does not decline with time, as constant correction is available from different X-ray sources. Number 3, it is robust to interference. You can detect these things anywhere in the galaxy. And number 4, it seems fit for the whole of outer space. But now things are about to get really spooky, because remember that pulsar clump that I was talking about before, that arrow-shaped clump? Well, at its termination point is a particular pulsar known as B1937+21, the most rapid of all known millisecond pulsars, and also one of only 2 pulsars known to emit giant pulses as well as optical pulses. Giant pulses, by the way, are enormous bursts of electromagnetic radiation that make this pulsar stand out from all others. Why would this very unique, very unusual pulsar be located at such an important point in the galaxy from a navigational standpoint? And on top of that, the tip of this arrow-shaped clump is an equally unique millisecond pulsar known as B1957+20, which is, coincidentally, the second most rapid pulsar in the sky and is distinguished as being one of just 4 eclipsing binary millisecond pulsars. And also, this second pulsar is unusual is that its periodicity is 3.18% longer than that of the first millisecond pulsar we were talking about, which is the same percentage that its position in the sky surpasses the longitude of the first pulsar. In other words, its periodicity is exactly proportional to its position as far as the galactic plane is concerned. That is an unbelievable coincidence, so unusual that it seems like a very artificial thing and not a coincidence at all. And so here is a revised list of possibilities regarding pulsars that I think astronomers really need to take a hard look at. Number 1, all pulsars are natural. We're just lucky that they provide stable clocks and such an accurate navigational system. However, number 2, pulsars are standards. That is to say, they are natural, but extraterrestrial civilizations use them for timing, positioning, and navigational purposes. Communications are galactically tagged and time-stamped with a pulsar standard. Or number 3, pulsars are natural and alterable. Some extraterrestrial civilizations have the technology and capability to jam, spoof, or interfere with a natural pulsar positioning system to make them more useful. Number 4, pulsars are artificial and used for navigation. Only a few millisecond X-ray pulsars have been modified by extraterrestrial civilizations for galactic navigation and timing purposes. Another option is that all pulsars are artificial. Extraterrestrial civilizations build them, even the new ones, by intentionally triggering supernovas. Once again, not beyond the realm of possibility, and given just how useful and strangely well positioned these things are, it becomes a more likely possibility all the time the more we look at this. And then finally, artificial pulsars are for us. Not only are extraterrestrial civilizations building pulsars, but they're also sending us Earth-specific messages. Once again, given the position of some of these things and how perfectly positioned they are for us to be able to see them and make use of them, that doesn't seem to be entirely beyond the realm of possibility either, although personally I find it to be highly unlikely. I really don't think our civilization is that important to other extraterrestrial civilizations throughout the galaxy. So when it comes right down to it, Are pulsars useful for navigation regardless of their origin? Absolutely, and unbelievably useful. Are they artificial? Well, that's a matter that really needs to be debated a little bit more honestly these days. But of course, given the attitudes of the scientific community, I think that that is highly unlikely and that these notions are going to be scoffed at by most astronomers and scientists. However, at least they were taken seriously enough to be published in a couple of well-respected peer-reviewed journals. And I have both of these papers linked in the description, by the way. Thank you very much for watching. Please like, please subscribe, and also please check the description for various ways to keep this content coming and to support my tour. And as always, stay angry about space.